So hello everyone, so today we are going to solve this subset problem number 78. So let's move to the problem statement first. Given an array of integer nums of unique elements, return all possible subset, the power of set, the so the solution set must not contain duplicate subsets. Return the solution in any order. So we know that if there are n element in particular collection, then total number of subsets which are possible would be 2 raised to n, right? Same is the case here. If you see, there are 3 elements, so total number of subset is 2 raised to 3, 8. There are 1 element, so total number of subset is equals to 2 raised to 1, which is 2. And one more condition which is given, that solution should not contain duplicate subsets. Since all elements are actually unique, so we won't be getting any duplicate subset. First thing that. So now let's come back to the explanation part. If suppose the size of the collection itself is 3, so we know that if 3 is the number of elements present in the collection, then how many subsets are possible? 2 raised to 3, which is 8. So that actually we can represent using binary numbers, right? 8 possible subsets can be represented by 8 binary representation, like 0 0 0 will be 1, 0 0 1, then 0 1 0, then 0 1 1, then 1 0 0, then 1 0 1, then 1 1 0, then 1 1 1. So how come we came up with this idea? First let's discuss that. If you see how many representation of subset can be there for n is equal to 3, so total 8 representations can be there. So first representation would indicate that there are no element in that subset, so empty set is also a subset. So that's the first rules, and that can be done by using 0 0 0, this combination, right? So this will actually form the empty subset. Now every single element will also represent a subset, right? Isn't it? So if you see, the single element that would represent a subset will be marked by the set bit. So if you see, there is only one set bit which is at the last place. So these numbers actually corresponds to the position of the given input, right? So if the input given here is 1, 2, 3, so those inputs can be basically represented by bits, and that bit will basically signify whether that particular element will be there or not, will be present or not present in our given subset. So how we gonna do that? We will be using two representation, 0 and 1. 0 will represent that particular element is not present in our subset, and 1 will represent that particular element will be present in our subset. So if you see the first this 1 2 3, so the first subset will be 0 0 0. So that means 1 won't be present, 2 won't be present, 3 won't be present, right? Means 0 indicates the 1. First 0 represents the position for the 1, second 0 represents the position for the 2, and the third 0 represents the position for the 3. So their position basically we represent by binary numbers, and if their corresponding position is 0, that means that particular element should not be there in the subset. So if you see the second subset, this will be our second subset, right? So if you see the second subset, the position for the 1 in the second subset is 0, that means 1 won't be there in our subset. The position for the 2 in our subset is also 0, that means 2 won't be also present in our subset. The position for the 3 in our subset is actually 1, that means 3 will be present in our subset. So in that way we actually analyze this. So this is how actually we're gonna form our all 8 subsets. Like this one, let's consider this as 3. So 0 basically represent the position of element 1. So 0 means 1 won't be there in a subset. This one basically represents the position of element 2, that means 2 will be there in our subset since it is set bit, that's why. And the last 0 basically represent the position of element 3. That means 3 won't be present in our subset because it is unset bit, right? So this is how actually it is visualized. So this is S5, this is S6, this is S7, and this is S8. So now coming to this will be empty subset as we discussed. And now coming to the second subset, this will be like we will be having only 3 in our subset since the third position is set bit and third position is represent element 3. If we go to S3, then it will be nothing but element 2 itself, right? Since the second bit is set and second bit actually represent the position for element 2, so that's why element 2 will be there. And if we see S4, this S4 basically has two set bits at first position and second position. So first position and second position are represented by element 2 and 3 itself. So since both their position contain set bit, so we can actually directly fill them here 2, 3. Okay. And now 1001 basically represent the position of element 1, so 1 will be there in our subset. 0 basically represent the position, first 0 actually represent the position of element 2, so since it is unset bit 0, so 2 won't be there in our subset. And similarly the last 0 which is also unset bit actually represent the position for the element 3, so element 3 will also not be there in our subset, so it will be only just element 1. And similarly it will be 1, 3. Since the first bit and the last bit is set, so first bit represents the position for the element 1 and the last bit actually represents the position for the element 3. So since their bits are set, so they will be present in our subset. 110 means 1 will be there, 2 will be there, and all are 1 means all 3 elements will be there, right? So these are the subsets for a given. So let's, since we have analyzed this question, so now let's solve it. So let's calculate the value of n first, which will be nothing but nums dot length, right? Now we have to form this binary representation, right? So that binary representations are nothing but our mask. So basically we can actually start it from 0 and we will move it till 2 to the power n, right? So 2 to the power n we can find out by using this. Like for n equals to 3, it will go from 0 to 7. So basically it will go less than 2 raised to 3, which is 8. Then I plus plus, right? Now we have to go over their bits, right? For j is equals to 0, j less than, how many bits are there? Since there are 3 elements, so basically we can say there are 3 bits, so it will be 0th bit, first bit and second bit, right? So that's why j will run from j equals to 0 to j less than and j plus plus, right? And now if we see, if I and 1, like first we consider this first representation, right? If we are doing it for the first mask, so how many bits will be there in the first mask? 3 bits will be there, so we will be checking for each bit. and find out which all particular bits are set bits in this first representation, and for that we are actually using this second loop to iterate over all the bits and check which particular bit is basically a set bit, and accordingly we will take its corresponding element and add it in our answer, right? If I and 1 is greater than 0, if greater than 0, that means element is a set, that particular bit is a set bit, right? So we can add it in our uh, temporary answer, temp answer, right? We can do this by this, and here we can actually initialize our temp. Temp will be nothing but a list of integer. Temp is equals to new array list. So basically this will hold the subset, and we will also need a final answer variable, which will be collection of all subsets that has been found after going through this entire loop, so that we can represent here, initialize here new array list. So once this inner loop gets completed, right, we would be having our first subset ready, so that we can directly add it in our answer. And then finally we can return our answer. Okay, so here we will need one more bracket. ans dot add list of integer cannot be converted. Oh yeah, this will be list of integer. So here we got our answer. Let's take it for the second case. Okay, we are getting the answer. Let's submit it. Okay, we submitted our answer and it got accepted. So hope you understood the problem statement and also the solution. Now let's discuss the time complexity of this solution. Since we are forming this binary representation, which actually represents the mask value, and whose bits represent the position of the elements. So basically, if there are n elements, then we would be forming 2 raised to n n mask. So the first loop will run for 2 raised to n times, right? From 0 to 2 raised to n minus 1, that will be equal to 2 raised to n times the first loop will run, and the second loop will run for n times. So it will be like n into 2 raised to n. Time complexity will be n into 2 raised to n, and the space complexity will be, since we are using extra space of order of 2n, so space complexity will be 2 raised to n. 2 raised to n plus this particular temporary array list that we have created for storing the one subset at a time. So this will be actually n plus 2 raised to n. So let me write it here. Time complexity will be is equals to 2 to the power n into n. Space complexity is equals to, again we are using an array list to store all the subsets that we have found. So there are total 2 raised to n subsets, so that's why the time space complexity will be 2 raised to n. Plus we are also storing temporary array list, basically that is storing one subset at a time, so one subset can be of max length of n, so that's why it's n. So this will be our overall time complexity and space complexity. Okay, so thanks for watching. Please do like, subscribe to my channel for more such contents. Thank you.